Hello everyone, welcome to this video where we're going to be looking at how we can move between Autodesk Revit geometry and bring that data into an Altair solution like Inspire, SimSolid, or Hypermesh. In this case here, we're going to export the geometry using a step file format, but there are other formats available as well. Now this example that we're going to be using is one of the sample models that was provided with Autodesk 2025, Revit 25, excuse me. And this is the advanced sample family model. And you can see it's essentially a shelter that's hanging off the side of the building. And it's got a variety of supports, these transverse cantilever beams that are basically connected with these angled slats, if you will. And one of the things I want to point out right away is that the geometry that's getting set up here, or getting imported rather, we want to make sure that it represents our intentions for actually building this structure as well. Because that's what's going to be reflected in Inspire or SimSolid or wherever it is that this model ends up. One example of this where it might not necessarily represent our intentions, however, is if we're looking at this longitudinal slats here, we can see here that they are actually continuous along their entire length, even though in reality they would have to pass through this transverse cantilever somehow. Or perhaps they're broken up between each one of these cantilevers, but that's not reflected here in the geometry at the moment. One option would be to break that up in the source program, in this case here Revit, before we import that. But obviously we can handle that geometry in a tool like Inspire, for example, amongst others. So let's just keep that in mind, something that might come up later on. But I'm going to go to the File menu, and I'm going to get ready to export this. So I'm going to go to the File menu, choose the Export option here, and we have this field that says CAD formats. I'm going to choose this, and we can see the different CAD formats that we can export this Revit model or this Revit geometry to. And I personally prefer the step file format of these that are available. However, there's a number of other formats that our tools do support that you could consider as well if you had a reason to do so. So I'm going to go with this step option, and it's going to import this or export this 3D CAD geometry from the Revit model into a format that the Altair solutions can read. And we get this option, or this display, this step export settings that's showing us a view of what's going to be exported, as well as some different parameters that can potentially be adjusted. I'm not going to worry about this. I'm going to stick with the defaults for now, but feel free to adjust if you see the need. I'm just going to click the next button, and it's going to ask me to save this file. And I'm going to save this here. I'm just going to call this test step, and you can see the file type that it's writing is a step file. I'll click OK. And what we'll notice here, I just brought over this this folder that I am actually writing this file to, and we can see that test step file indeed exists there, which is an indication that that export has successfully happened from Revit. So my next step is to go into Inspire, which is one of the Altair solutions that we could use to read in this geometry, perform analysis on it, even manipulate it if we wanted to, or perform different optimizations on that geometry. So within Inspire, we can obviously import geometry from other sources, but we can also build that geometry ourselves from scratch or by building off of imported geometry. So I'm going to go to the File menu, and I have this import option. I'm going to select that. And you can see here I have this test step that I just wrote. I'm going to import this, clicking Open. And you can see here that it's brought in this geometry just as I saw it within Revit. And one of the good sides of that is that we know exactly what's coming in. One of the downsides is that it may not necessarily always have the kind of constructability that we had in mind when we're considering this. And if we didn't manipulate that or correct that issue in Revit, it's still going to exist in Inspire as well, but we do have tools to handle it here as well. Just to go back to my example here, if I look at these diagonal slats, I can see here that they are continuous along their entire length, and there is no holes in these transverse cantilevers that are going to be supporting those. So I could look at ways that we might want to cut those from one another. So for an example here, I'm going to switch my view to the top view, and I can use this Boolean command in the geometry window, which allows me to choose the subtract option. And I can basically say wherever these objects are overlapping, I'm going to subtract that type of geometry. And I need to specify my targets. My targets in this case are going to be these longitudinal slats. and I need to select my tools. And my tools in this case are going to be basically these transverse cantilevers. And I'm going to switch my view. Let me just go to a view that I like. And we have these options once we've selected our targets and our tools to decide whether or not we want to keep our tools. So again, the tools, they're showing up in blue. And the targets, they're showing up in this kind of orangey color. We can choose whether we want to keep the tools and whether we want to remove the imprints of those tools or not. I actually want both of these checked because I do want to remove the imprints from my particular object there, my targets. So I click apply, and I'm going to right click and end this command. And you can see here now what's happened. It might be kind of subtle, but we can clearly see there is a disconnect between each one of these segments of our longitudinal louvers here. And so what I can do right now is I can see that they are still one single object, but I can actually separate these bodies into parts. So I'm just going to select all of these here, and I'm going to right click and I'm going to say convert these bodies to parts. And now they're all individual segments rather than one continuous segment that might be broken up or even not broken up like we saw before. And we can actually display these so we can look at auto colors, so we can see these in different colors and just confirm again that they're not the same part. Now we can go ahead and run an analysis by applying our boundary conditions, our loads, our material properties and connections and so on. And I've already done that. I went ahead and did that already here. So if I just go to my example file, and here's the file that I was looking for. Unfortunately, I have several different versions of geometry that looks quite similar in Inspire, so I got a little bit confused. But this is a geometry with the boundary conditions and the loads and materials and connections all applied. So you can see I've got a variety of different pressure loads on these louvers. I've also got some contacts defined. As you can see here, they're all assumed to be bonded connections or contacts between each one of these different parts that we imported from our CAD geometry. Now I'm going to go ahead and analyze this. That was my ultimate intention here, and I'm going to analyze it for deflections and stresses and so on using the SimSolid solver, which can handle this 3D geometry without the process of meshing first. However, if we did want to take a traditional FEA approach, Inspire also allows us to use the OptiStruct solver, which amongst other things can run an analysis, but also optimization and so on using more traditional FEA approaches. So I'm going to go ahead and run the analysis. I'll click Analyze button here. Run SimSolid analysis. We could also do the same thing through the SimSolid program as a standalone program. And I'm going to run it just with the default conditions. And you can see here we're getting a clean solution. It took just a second or two to run. I click on View Now to look at the results. And here I can see the deflection of my model. I'm just going to hide the initial shape so we don't need to see that. And we can see how it's performing as we apply these loads to our model. And we could get this out extremely quickly without having to redefine our model or mesh or anything like that, just from having that geometry created already in Revit. Now, if you'd like more information on Inspire, SimSolid, or any of the other Altair solutions, please feel free to check out our other YouTube videos on those topics. You can always reach out to us if you have any specific questions. And if you're interested in going from Revit to other Altair applications, we also have applications that interface with Revit like S-Frame for general structural analysis and design, as well as Foundation, Timber, and more. So please feel free to reach out if you have any questions about those.